All right, everyone, welcome back. And today I figured I'd talk about some local entomology news. If you aren't following me on Rumble, get on there and follow and like the video so I know people are watching. I can see the numbers going up, but I would like to see some more interaction, see some more comments and follows and things. So hop on Rumble and do that for me. I would really appreciate it. But in local entomology news, if you're in the mid-Atlantic region, the number of green June beetles this year has really exploded. And so local news has been reporting on this. They're just everywhere. And if I go outside now, I see them swarming around the trees, probably for the last week or two, coming out of the grass. At night, they're all over the place. There's a bunch dead on the ground that are being eaten by the birds. And so local news has picked this up. And I figured I'd use this as an opportunity, one, to correct kind of some of the things that they're saying, but two, to explain some stuff about insect population dynamics, especially Catinus nitida. This is right here is the green June beetle. They're fairly large. You've probably seen them around if you live in the eastern United States. They occur all over the eastern United States from New York to Texas, basically. And they're always out in the summer. They are usually found either in the grass or around fruit trees. And they're fairly large. They're about the size of a quarter, very metallic green. Their underside is incredibly iridescent. The birds like to pick on them quite a bit because they're kind of defenseless. If you're a woman and you have a lot of like floral or fruity perfume on, these will generally fly into you. And they can quite hurt when they hit you because they are large and they do fly at relatively high speeds and they're rock hard. Heavily armored scarabs, but if you're a woman and these are flying into you, they're not trying to bite you or attack you or anything like that. What they smell is usually the floral or fruit perfume or shampoo or soap that you're using, because those products usually contain a chemical called eugenol, which is a very potent kind of fruity floral scent oil that is used in that is actually naturally produced by plants, but is used in the baits for these insects, and it's extremely effective. They can smell it from long distances, and they basically think you're a giant piece of fruit or a giant flower. That's why they're flying into you. I've known quite a few women that have gotten these stuck in their hair because their legs are quite spiky, and people don't like it very much. But I worked with these for several years. They're one of my favorite insects. So I wanted to talk about this a little bit. I've seen a ton of these emerging. In Virginia, they're talking about this as well, that at Virginia Tech, they've been asked about this. And basically their response is, yeah, it's really high this year. Beetles are really high this year. It's because it's raining. And the rain does play with it a little bit, or play into it a little bit, but there's more going on here. So this is Catinus nitida. But you may have noticed other June beetles emerging. Japanese beetles are in high numbers. And there's a little bit going on here. So the rain does have to deal with it. The rain softens the earth, but it's not actually predictive of the emergence of these insects. So there's been quite a bit of work done on the emergence of this. These are two papers that you can look at if you want, predicting the emergence in a Midwestern population of green June beetles, and then an update to that paper done about 5 years later. And this explains pretty well, these papers explain pretty well what is going on with Catinus and other beetles in the summer months. So I figured I would draw this out so you can kind of go along with what's going on. So most of these scarabs, Japanese beetles, green June beetles, some of the brown June bugs or May bugs that you see around, they usually have 1 year life cycles, and they spend the majority of their life underground because they generally feed on grass roots and plant roots. So let's draw some grass here, and they have their little roots going underground. The females lay their eggs underground. They usually dig underground. They lay an egg, which hatches into a larva in the summer. So they're usually C-shaped larvae. For Catinus, let's make him happy. For Catinus, they're very large larvae. Usually when you see them above ground, it's because there's been a very heavy rain, and they're kind of drowning, so they come out of the ground. They usually crawl on their backs with their legs in the air, and that's pretty diagnostic that you're dealing with a cotinus. And they can be well over an inch long. They're big, fat grubs. The birds like them quite a bit. So this grub lives underground, and it eats these roots. It doesn't move around a ton if the grass is dense enough, but they get very, very large by the end of the year, or by the end of the fall, really. So by the end of the fall, you have these very large grubs, very big jaws, feeding on the soil, under the soil, on the grass roots. And as it gets colder, they move deeper underground for the winter. The deeper they move, the warmer the earth is. It kind of stays at a constant 50 or 60 degrees. And that's how they spend the winter. And then in the spring, this is kind of the summer. And then in the spring, they move up. They move back up in the soil. And as it gets warmer, they pupate. So this is the first instar. This is the first stage of development. This is the third instar, the third stage. The third instar moves back up, and then they continue development in this region. Let's draw another little grub here. So this is the third instar, and he's moving back up. He's happy. This is where something that we can actually predict their emergence. It's something called the degree day model for insects. And basically how this works is insects are, I'm going to say cold-blooded. We don't use the term cold-blooded in entomology. It's poikilotherms. I can't remember the word off the top of my head. But they are their development is entirely dependent on the local temperature. How we predict their development is degree days. And basically, this is cumulative degree days. As the temperature increases, their rate of development increases. And once that temperature is above, for cotinus, is above 10 degrees Celsius, their development accelerates. And as the days get warmer, they, over a 24-hour period, as long as it's above 10 degrees, they accumulate degree days. And in this case, they need something like 888 degree days to emerge as adult. And how that calculation works is you take average temp minus 10 degrees C equals the degree days for the day, and then you accumulate that over the course of the day, and then over the next day, and over the next day, until you get to 888 degree days. So in the early spring, so this calculation generally starts at March 1st. So you have a biofix of March 1st. This is the day that you start counting, March 1st. So you have 0301, maybe you have, maybe it's, I don't know, the average daily temperature is 11 degrees C. So this is the daily temp. Daily average is 11. Then the degree days is 1 degree day for the day, because it's 11 minus 10 degrees C. And then on 3, let's say it's 12 degrees C is 2 degree days. And you do this until, usually it's like June, let's say June 15th equals, I don't know. Let's say it was, in my area, June 15th was probably close to 30 degrees C. So this would be 20 degree days. And you add all these numbers up until you get to 888 degree days. And that predicts the day that the green June beetles would begin to emerge. Their development isn't water related, like rain related, like this article says, it's temperature related. But water does have something to do with this. So I want to get into that. So when these beetles move back up into um, up into the soil column during the spring, they begin to pupate up here. So let me draw a little pupa. So they have their wings folded across, usually. They have big ol' eyes. Segmentation. You might be able to see some mandibles on here. They usually have their antennae visible. And so they're pupating up here. And what these types of beetles do is they build a pupal chamber. And this is a thickened mud chamber that acts as a protective shell around the pupa. Because they're basically completely defenseless. They can't really move in this. They can wiggle, but they can't really move around. So they're in this pupal cell, pupating, minding their own business. Let's say that you have a particularly dry year, and it hasn't rained all spring, very, very little rain, and in June and July in particular, it's been very dry. So this soil is rock hard. Even after they've accumulated the necessary degree days, there is very little chance for them to move out of this now rock hard pupal chamber to the surface of the soil, and so that they can climb up and fly away. When this happens, you do still get a lot of beetles emerging, because you're talking about populations in the millions. But many of the beetles die in the soil because they just can't get out. So they end up starving to death or dehydrating in the soil, and they're dead. When you have a wet year, you end up with the opposite, which is kind of what we've had this year. You get a lot of consistent rain. It doesn't have to be flooded or anything, but you get a lot of water coming in, and this soil is now saturated and it's pretty muddy. So these insects, once they finish pupating, they can crawl out really, really easy. So you have a relative spike in the population because more of the adults are surviving the pupal stage. They're surviving the pupal chamber emergence. They can actually get out. So that's what we're seeing, I think, this year in the mid-Atlantic region is we've had really consistent rain this year. It hasn't been soaking wet, but it has been pretty regular. Every week we get a rainstorm, and it's kept the soil nice and moist, and these insects are now able to emerge. So we have a lot of beetles emerging this year. It's been kind of crazy walking around at night. You're constantly getting hit by bugs. Which is probably a good thing, although these creatures are pests. The green June beetles are serious pests of fruit trees. They are attracted to ripening fruit. They are really good at eating ripe fruit. So they are a problem, and that's going to be an issue for farmers. But as far as like the local ecosystem, things seem to be doing really good. So that's that story today, and I'll see you guys later. Thanks.